Hello and welcome to Unit 4, Part 3. My name is Mr. Bell. Today we're going to talk about solving systems by elimination. This slide says to solve the following systems of equations, we're going to use a different method than graphing. Last unit we put them in slope-intercept form and graphed. This unit we're going to do something called elimination. So let's get started. Number 1 here says x plus y equals 5 and then x minus y equals 7. Well, if you'll notice, when they're lined up, when the letters and the like terms are lined up, they sort of create columns. And what you're looking for is you're looking to add vertically the columns, and you're looking for something to eliminate or to cancel each other out. In this case, if you'll notice, the plus y and the minus y, they'll cancel each other out. They're opposites of each other. So if I added y plus negative y, they cancel. But if I do that, I need to keep on adding all the other columns as well. X plus x makes 2x. 5 plus 7 equals 12. Now I'm able to solve for the other letter. Divide both sides by 2. My x value is 6. Remember, though, that when we graphed, the answer was where the two lines crossed at the point. So once again, the solution is going to be a point to a system. The way you do that now is take the x value that you just found, x is 6, substitute it in place of x in either one of your original equations, and then you can solve for the other letter, and I'll do it in green. So in place of the x, I'm going to plug in a 6 plus y equals 5, and that came from this top equation that I chose. Now I'm able to solve this one for y by subtracting that positive 6 to both sides, leaving me with y equals negative 1. That's what goes in the y spot here of our answer. Now take a look at example 2. You're looking at making sure that the y's and the x's and the numbers are lined up, and we're looking for anything that'll cancel in the columns, and it looks like this time the x's will cancel. So let's begin that process. If I add my columns, the x plus negative x cancels. Continuing, 4y plus negative 3y leaves me with just 1y, or y. 5 plus 2 gives me 7, and there's half of my answer. Don't forget, though, to get the x value, we're going to take this value of 7 for y, substitute it in place of y in either one of the original equations. I'm going to do the first one. So I'm going to rewrite x plus 4 times y equals 5. But in place of that y value, I'm going to put what y equals, which is a 7. Working this out, we get x plus 28 equals 5. We'll subtract the 28 from both sides, leaving me with a final value of negative 23. The next two examples are a little more complicated. Take a look at number 3. If you notice, none of my columns are opposites of each other and cancel. Well, what you can do is you can multiply one of your equations by any number that you want to, as long as you multiply every part of that equation by that number, and you can turn it into something that will cancel. For example, if I wanted to eliminate this positive 2y, well, I need the top value to be a negative 2y. What can I multiply negative 1 by to get a negative 2y? Well, I can multiply everything on top here by 2, and let's look at the results that I get. 2 times 4x gives me 8x. 2 times negative y is negative 2y. Do you see now why I chose to multiply by 2? So that the y's will cancel. And then, continuing, 2 times the 9 gives you a value of 18. Now that I have changed that equation, I can do like I did on the last examples, add my columns and eliminate something. In this case, my y's eliminate. I'm left with 11x equals 4 plus 18 is 22. And divide both sides by 11 to get an x value of 2, which is half of my answer. Don't forget to take that x value and plug it in for x into one of your other equations. It doesn't matter which one. I'm going to do the second equation this time. So 3 times x plus 2y equals 4. In place of that y, I'm going to plug in the 2 that I found x to be. Sorry, in place of the x. 3 times 2 is 6 plus 2y equals 4. We'll subtract that 6 to both sides. 2y equals negative 2. and divide both sides by 2 to give me a y value of -1. Now we have solved that system of equations by elimination. On to the next example. This one is probably the hardest example of the day. Our x's can't eliminate, our y's can't eliminate, and our numbers can't eliminate at the moment. So instead of just multiplying one of the equations by some number, because I can't multiply 2 by anything to get 5 without using decimal numbers or fractions. So sometimes you'll have to multiply both of your equations by some numbers in order to create things that will cancel. A little trick that I like to do is whatever the top coefficient is, I like to multiply the bottom equation by that number. Whatever the bottom coefficient that I want to get rid of, I multiply that one on the top. The only thing you have to remember, and you can look real quick before we start working this out, is that by doing that, 2 times 5x is 10x, 5 times 2x is 10x. So they'll cancel as long as one of them is positive and one of them is negative. So double check and make sure that you use the correct factor to multiply by so that you get a positive on top or bottom and a negative in the opposite spot so they cancel. So let's do some multiplication here. On the top equation, 2 times 5x is 10x, 2 times 7y is 14y, equals 2 times -24 is -48. Now we got to do the second equation. -5 times 2x is -10x. Notice how they'll cancel in a minute. -5 times 3y is -15y. -5 times -11 is a positive 55. Now I will add my columns and eliminate my x's. 10x minus 10x is 0. 14y minus 15y is -1y. -48 plus 55 leaves me with a positive 7. One last step to undo multiplying by -1 is to divide both sides by -1. I get a y value of -7, which is half of my answer. Don't forget to take that y value. You can plug it into any of the original equations or the two that you changed for y. I'm going to plug it into this second equation at the top for y. So I'm going to rewrite my 2x plus 3 times y equals -11. In place of that y, I'm going to put the -7 that I just found. Now I'm left with 2x minus 21 equals -11. We'll add 21 to both sides, leaving me with 2x equals 10, and divide both sides by 2, leaving me with an x value of 5. All right, thank you for watching and hope this helps.